Okay, around the table, is there alien life?
I'm going to split the baby a little bit in terms of my answer by changing the question a little bit to, do I believe there's alien life? Because, from a scientific perspective, the null hypothesis is no. We don't, we don't know at the moment. But if I believe there is alien life, I'm going to say yes, given that, the number of planets that seem inhabitable, even within our limited neighborhood, is high. The universe is really big, and I think evolution's a pretty powerful force, so yes.
And no.
Yes and no. Well, yes, but if you ask me if I believe, not if I know.
Okay.
Yeah, I think there's alien life, but I think when you get into the sort of debate about intelligent life, I think intelligent life will turn out to be quite rare on a cosmological scale. I think we'll find slime out there, maybe some simple multicellular organisms, but things that actually build alien megastructures will be very rare.
Yeah, my take on it is that I think that it depends on what we're saying. If we think that life is very simple reproducing crystals or molecules, that's possible, but not inevitable. I think the idea of there being things like us out there is extremely unlikely, and things like us that are around near us and at the same time as us, I think is pretty unlikely, given what we know about life on Earth. But we only know about one kind of life. So maybe our imaginations need to be stronger.
I'm going to say yes too, but with a caveat of, are we talking about past or present or future as well? Because like we've done a lot in 200,000 years, but we have only actually been here for 200,000 years as humans. So it's sort of naive in a way to think that there would be something that is evolved at the same time and more or less the same pace that we would communicate with it in those 200,000 years, as opposed to the 14 billion years, more or less, that would be in here. But when you think about how much we've done in 200,000 years, we've gone from cave dwelling to robot building society in 200,000 years. That's actually quite a lot. So we've developed quite a lot as well. So yes, I'm going to say yes, but the question for me is more not is there alien life, but will we ever find it?
Okay.
I would say yes, but that's purely my hope more than anything else. If there is one thing that I want to happen within my lifetime is somebody to find alien life. So for me, it's more coming from my wishful thinking and optimism than anything else. But I'm also concerned. I think there's more than what you said that we need to be worried about. It's not just that we have not been here that long, but we have not been technologically advanced long enough that we can advertise ourselves to the universe. That's only been in the last 1,000 years at most, where we've done anything of the scale that we can advertise ourselves to the universe. And there's strong evidence to point out that we may not last very long if we go at the pace we're going now. So if it is inevitable that civilizations rise and fall over a few thousand-year time scale, then the chances that we will coincide with another civilization in our backyard becomes infinitesimally small, despite the millions of possible habitable planets. So that's my dilemma at the moment.
I think everybody said everything I wanted to say. I would like to think, yes, there is life out there. I don't know, my issue would be how you would define what that life is. I mean, again, I think like Matthew, and it's whether or not it's intelligent life is debatable, and whether or not we are in the right time frame to find that, and whether or not they and us have the technology or the desire to actually try and find each other, because they may not, they may have no inkling of life out there, and they may not care. So I think there's all that to take into consideration, but we'll talk about that more later.
Yeah. Well, one of the things that Enrico Fermi, the Italian physicist, said, so well, if there are aliens, where are they? And we've all kind of said, well, maybe we're not in the right time space, or they aren't clever enough or developed enough. But you can imagine that if we manage to get over the various humps we're going through now, and we carry on for another few thousand years, we will be filling the universe with our probes. Well, I guess we'll be spending out spaceships and trying to find stuff, or saying, hey, we're here, come and join us. Or there's good eating here, come and join us. So why haven't they done that?
Well, I think the Fermi paradox is one of those conundrums that's if you're a science fiction writer, like I am, it provides infinite grist for story ideas. You can just come at it over and over again, and you can find so many angles, so many possible resolutions to the Fermi paradox. I mean, one of the things I think about is that if, say, we think a few thousand years ahead, what if our understanding of the universe reaches such a complete state that we realise there's actually no need to go beyond our solar system? What if we decide that every other solar system out there is just boring? Like we've sampled enough that actually we don't need to go and see the 1001 exoplanet because they're all basically the same. What if beyond a certain point, alien life becomes very sort of hermetic, quite content just to sort of sit in its own sphere and just think? There'd be no need for contact. Perhaps that's a resolution of the Fermi paradox.
But I think as humans, that's one of our sort of that's in our makeup, I think, is we are naturally very curious, and even if it is, they're not, 1001 exoplanet is boring, you might think, but the 1002 might not be.
But you don't need to turn over every stone on a beach, do you? Once you've sampled a few pebbles, you think, well, okay, I get pebbles now. And
but you're in the minority because 99% of the human population wants to turn that other stone over. That's human nature. We're extremely optimistic, despite what people might think that we're all pessimists and we want to kill each other. But actually, by nature, human beings are extremely optimistic. We are always hoping that there is a pot of gold under the next stone.
So it's a bit like Pandora's box. We want to know what's there, what could be there.
But I think there's always often a bit of arrogance, I think, when we talk about this type of thing. Where are the aliens? Why are we so special that the aliens want to come see us? I mean, there were a lot of answers to Fermi about this. I mean, one of which is this idea of the zoo hypothesis, right? That they're there, but they have the means by which to prevent us from sort of detecting us. But one of the other answers is, well, what if they're sort of aware of us, but they're just like, why bother with this group? So, as humans, we're anthropocentric, and we just assume that they must want to come and talk to us. So that's one possible answer. They just don't care about us.
I suppose there's the practicalities as well of, the distances could be massive, and that brings in time issues as well. And then how do you cross sort of time and distance? So maybe they did try and talk to us back when we were cavemen. Maybe they didn't.
Yeah. So I guess one of the problems is that you're saying, we should be sending out probes and we'll be doing this and we want to investigate. But okay, so we've just gone to Pluto and the New Horizons satellite probe was sent 10 years ago, and so they've just been putting pictures up on Twitter of them all cheering 10 years ago when the rocket went up, and now they've got these unbelievable pictures. Okay, so I can just about imagine investing that kind of length of time. But in a probe that is going to take, decades, centuries to get, and then we're not going to get the information back if we're still here for more centuries. I mean, what's the point of that? Would we really invest so much time and money, do you think?
We have the radio horizon. Let's not talk about probes. Let's talk about the radio wave horizon, which is 80 years, 100 years old now? So 100 light years, that's how far our information has traveled. One way of looking at it is, okay, there's no intelligent life coinciding with us in space and time in the 100 light year horizon. Yeah. Or they have not advanced, or maybe it's not possible to detect radio waves that low intensity that far out, because that's as far as we have advertised.
Well, we really only know what's going out to 50 light years.
Yeah, exactly. Yeah.
So it's even smaller, isn't it?
So
why is that?
Well, because you need to allow the return time as well.
Oh, okay.
We've been broadcasting for 100 years, but if aliens got our signals 50 years ago, we'd only now see their spaceships arrive.
But that's assuming that speed of light is a limitation, and I don't necessarily buy that assumption. And we can get to that later, but I don't.
You've got to know that the actual signal itself is deteriorating as it goes, so we don't actually know how far it will go as well.
Well, it will travel infinitely. It will travel infinitely.
No, but the actual signal itself will deteriorate so much that it won't be able to be picked up anymore.
Well, the information content as well.
Kind of obscure signals.
But yeah, who knows?
So what's the weakest signal we think we can detect and the furthest away with your fabulous instruments? How far away can you detect this mobile phone?
So the telescopes that there are now, radio telescopes that there are now in Green Bank in the US, and probably Parkes telescope actually in Australia, they could detect the equivalent of an airport radar signal 4 light years away on a planet that was 4 light years away now.
Okay, so a radar, that's pretty intense,
Yeah,
mind
it
you, a
is,
radar
yeah.
signal from a...
Yeah.
But we've got them, so that means if there was a star 4 light years away with a planet on it, they could see us within 4 years and we get the message back in
But in
Or
the
do we
lab,
need a relay of like a telescope or something that's 4 light years away?
Put it on the nearest star and then
in the lab though, we have single photon detectors. These are not science fiction objects. We can detect individual photons. So effectively, all we need is a repeating pattern of single photons, and we can detect that. This hasn't been mounted on a telescope or anything like that, but the technology very much exists. If we can do it in the lab, somebody else could very well put it on a
But if you
telescope.
put it on a telescope, it would just get kind of bleached out by the sun, wouldn't it? Wouldn't it
Well,
kind
it
of
depends
burn
on where
out
you put the telescope.
in the dark?
Dark side
Well,
of
where you
the
point
moon.
it, I suppose, is the criteria.
Well, not quite.
Stick the telescope on the other side of the moon, and you
Well,
can
it's in
detect
light.
light.
It's in light half the month.
But aren't we? We're thinking radio and photons. It's all part of the electromagnetic spectrum. Aren't we in danger of being a little bit parochial? I mean, aliens might be using. I mean, at the very least, they might be using gravity waves or neutrinos, or something we don't even know about yet. I mean, I always think this when we get really sort of bogged down in discussions about radio propagation, light propagation, it's kind of like worrying whether they can detect smoke signals, because they're just not going to give a toss about
Or they
radio.
might. Or they might.
Well, if they're actively reaching out to us, then they might sort of dumb down their technology to the point where we stood a chance of comprehending it.
Well, I mean, isn't that the thing with SETI? I mean, the whole the spectrum that they're looking at is the 21 centimeter hydrogen line, right? And the idea is they call that the watering hole, right? The idea that that's where everybody should meet, because every intelligent species should recognize hydrogen as the most abundant element in the universe, and we could detect that type of shift, but they may not, and they may be like, oh well, that's for dummies. We're gonna be looking in this
But it's like if they're having a private conversation between sort of super civilization over there and one over there, they're not going to be arranging things so that we can cheerfully intercept the signal. They could be using some completely private sort of telephone exchange between them.
Well, when you talk about the speed limit of light, for example, and saying, oh, we need the signal to come back, or when you're talking about electromagnetic communication and stuff like that, what I really think is, okay, we don't understand 90% of the universe. And the 10% that we do think we understand, we kind of maybe understand a little bit. So how can we actually imagine that we know how aliens are going to be communicating? And saying, oh, they haven't found us. They probably have. They're probably walking amongst us, but why would they advertise themselves?
What's the probability? Say probably with a very tiny probability.
Are you telling us something?
No, I'm not. If I was, I wouldn't.
That's a good reveal.
Not in this location. But the thing is, if they were, they're certainly not going to be buzzing hillbillies. That much we know for sure.
Why not? Why not? I mean, come on, if you want to know, if you want to advertise your presence, then you put huge, great, big metal dish in the sky. You write in the sky, "We are here," and we know. Then it's all sorted. We don't have any conspiracy theories. Nobody's going to be arguing about it.
I really like the idea of space graffiti.
If we were.
But I think there's a good point in that if they wished us to know of their presence, we already would.
Oh yeah.
Because they would have the energy. I mean, no matter whether they're here or whether they're transmitting to us, it would be an unambiguously resolved question by now.
Why do you think that though? Because you're assuming that they're more intelligent than us.
Yeah, I think they'll have been around for a bit, with this side, when we get into sort of evolutionary timescales. I think any civilization out there that's likely to be interested in communicating with us will have been around for millions of years, longer than us, and they will have, Dyson spheres and all nonsense like that. But they will be able to just hit us with such a powerful signal that we wouldn't have to build specialist equipment to detect it. We just see it.
Well, isn't there the possibility of incommensurability in terms of the ways in which we might communicate with them? If they're a totally different life form, they may already be communicating with us, but we don't have the faculties to pick it up. I think about it's called the Sapir-Whorf hypothesis, which I'm sure many of you know, the idea of sort of linguistic relativity that our language defines, and if their language is such that we just cannot comprehend it, then maybe they are, and we just
Well, we're not really looking for language. We're not really looking for intelligent communication. At the moment, all we're looking for is well-defined patterns in the electromagnetic spectrum. That's all we're looking for. We don't care what it means. We don't care about interpreting it. We don't care if it is a language signal or if it is a radio signal or whatever. We are scouring the electromagnetic spectrum looking for repeated or ordered patterns which cannot be naturally generated. That's it.
That's not it anymore though, is it? Because that's a passive way, which is what SETI's been doing for a long time, but now there's METI, which is the messaging on search for extraterrestrial intelligence, and lots of people are against this. You know, Stephen Hawking is one of them that's very much against. You know, should we be actively sending out messages into space? So yes, there's the passive way, which we've done for a long time now in terms of scouring the spectrum, but now we are actively putting messages out there as well. And so I think it was the anniversary of the WOW signal. Arecibo sent out 10,000 Twitter messages.
Good luck with that, aliens.
So they pointed it at where they got the WOW signal, and then sent out 10,000 Twitter messages.
That's Twitter messages. I mean, but I guess what I keep thinking about is, you brought it up. If there's life on other planets and it's gone through phases of evolution, we know we've had mass extinctions. So what's to say that they've not had sort of phases of mass extinction, and then we're just going to miss the window?
So I think it's interesting that though most of us said it's very unlikely they're going to be around as smart or smarter than we are at the same time and in the same place, we then skipped over that and all started talking about, well, they're here, they're walking amongst us, you know, why aren't they doing it? So the simplest answer is that they aren't there. They aren't there now in somewhere that we can see them. They might be in another galaxy far, far away, but they're not in our part of the galaxy at a time when we can see them, because getting to being a spacefaring civilization is in fact really, really difficult, because you're right, yeah, we've done it in the last, really, we went from living in caves, most of us, I don't know what, 5,000 years ago we had started to develop agriculture, and then hey, we've got people living in low Earth orbit. That's fantastic. Yeah. But that was not inevitable by any means, given the 3.5 billion year history of life on Earth. You know, it could have gone very, very different.
The 2001 Odyssey thing, where they came and they spoke to the Stone Age people.
Well, maybe they did that. Maybe that's why we're here. But we don't. So the probability, the possibility is, and I would argue the probability is, they ain't here. They're not there. We're talking into the void.
But you're talking about intelligent life capable of communicating with
the kind of things we've just been talking about.
Life.
That's a different issue, but I mean, I just think it's interesting. Perhaps it's just because it's more fascinating to talk about what they might be doing rather than actually saying, well, no, there's nobody there. We're shouting into the void.
But it's just to think if you think about going back to the Fermi paradox and things, even a really conservative estimate of it